Dear children, hearty welcome to today's class. Last class, we were dealing with Leonard Jones potential. Today, we are going to see one of the physical properties of liquids, that is vapor pressure. Here, we will have more explanation on vapor pressure and evaporation. According to the kinetic molecular model of liquids, the molecular arrangement of liquids are not that much close like solids. We have already seen that in the case of solids, there is close packed arrangement of molecules. But in the case of gases, the arrangement of molecules are random. When we look into liquids, there will be an empty space between the molecules among themselves. So here, if you see that here, when we look into the solids, the molecular arrangement is so closely packed. The molecular arrangement will be so closely packed. There won't be any empty spaces between these molecules. It will be closely packed. But when we look into liquids, there the molecular arrangement will be like this. There will be some empty spaces between the molecules, and there will be surface also in the case of liquids. And when we look into gases, there are more empty spaces between the molecules. The molecules are arranged randomly. Here it is solid, this is liquid, and this will be gas. So because of this arrangement of liquids, the liquids are incompressible. That means it is very difficult to break the bonds between the molecules. Then if we look into gases, the molecules are arranged randomly. Therefore, the gases are compressible. But in the case of liquids, it is incompressible because there will be an empty space between the molecules, and solids also incompressible. And this bond, the bond between these molecules are very difficult to break. So this connection, these intermolecular forces are very difficult to break. Since it is very difficult to break, the liquids can occupy the space where it is there. That means it can occupy the space of, it can occupy or it can have the space of that particular container. That means if the liquids occupy the bottle, it can have the shape of the bottle, and if it is there in a beaker, it can have the shape of that particular beaker. That means it can occupy that, it can have the shape of that particular vessel. Then that means the liquids are, the bonds in the liquids are very difficult to break. Then if we look into the density of liquids compared to the gases and solids, the density is nothing but mass by volume. Here, in the case of liquids, the number of molecules per unit volume is less than that of gases. That means the density is higher than that of gases. The liquid's density is higher than that of gases. Otherwise, we can say that the liquids are much more denser than gases. So these are some of the properties of liquids. Then if we list out the properties, what I said now, there are significant attractive forces between molecules in a liquid. In the case of liquids, the attractive forces are very significant. Because of these attractive forces, they are very difficult to break. The molecules are very difficult to break in the case of liquids. And here, the molecules in a liquid are relatively close together. Therefore, there is no free space or empty space between the molecules in the liquids. Then the next thing is the average kinetic energy of molecules in a liquid is a function of temperature. That means as the temperature increases, the kinetic energy of the liquids increases. That means the the movement of the molecules in the liquid increases as the temperature increases. The fourth point we have already seen, that is liquids are denser than gases. Then the fifth point is diffusion of liquids is slower than that of gases. That means the mixing of gases, if we mix gases, two gases mixing, that will be easy. But if we mix two liquids, it is very difficult compared to gases. That means the diffusion of liquids is slower than that of gases. That means diffusion means mixing of liquids, that will be slower than that of gases. Then if we have next, we are going to see the properties of liquids. First, we are going to see the evaporation, the property of evaporation. As we saw here, the molecules are arranged like this here in the case of liquids. They are having some intermolecular forces between themselves. And because of this intermolecular forces, they are very difficult to move from. They are very difficult to break away. So these molecules are having some intermolecular forces between them. Then what is evaporation? This evaporation is a type of vaporization that occurs on the surface of a liquid as it changes into the gas phase at any temperature below its boiling point. That is, when the molecules are here, in the liquid, the molecules are here, and these molecules are having some attractive forces. And when these molecules are having the attractive forces, the molecules in the interior is having some kinetic energy, and the molecules in the surface also having some kinetic energy. We know that the molecules here in the interior is very difficult to move because it is having an attractive force from all the directions. But in the case of liquids at the surface, the molecule at the surface, there is having some attractive force from all these sides, not from the upwards. So here the kinetic energy will be higher at the surface, but in the interior, the kinetic energy of the molecules, or the movement of the molecules, or movement of molecules are not that much easy. Then what will happen? The molecules at the surface will escape from the liquid state to gaseous state. That means that is evaporation. They will try to change their state from liquid state to gaseous state. That is evaporation. So when the molecules from the liquid state is trying to change to gaseous state, vaporization occurs. That is nothing but the evaporation. So evaporation is a type of vaporization that occurs on the surface of a liquid as it changes into the gas phase at any temperature below its boiling point. It can happen for a liquid when it is below the boiling point also. So this is about evaporation, the definition of evaporation. Now let us see some more details of evaporation. Here, if this molecule, if one liquid, suppose one liquid, that is ethanol we suppose. So if ethanol is evaporating, means if that room is having a high concentration smell of that ethanol, then the evaporation of the ethanol will be less, because the room is filled with the smell of the ethanol. That means the high concentration of the evaporating substance in the surrounding gas significantly slows down evaporation. What is the reason for the slow down of the evaporation is that room is full of ethanol. Because of the smell of that ethanol, the evaporation of ethanol in that room is slow. Then as I said, when the molecules in the liquid are trying to collide. These molecules are trying to collide, and there is an intermolecular forces also. It is automatically happens in between the molecules in liquids. So when the intermolecular forces happen, or when the molecules are having an interaction, they will exchange some energy, and at a particular time the surface absorbs enough energy to overcome the vapor pressure. So sometimes these molecules are able to overcome the vapor pressure, then only the evaporation happens. Okay. Then we have seen when the evaporation, we are all familiar with when we pour water on the roof for cooling effect that we are doing in our day-to-day life. So what is the reason for this cooling is that when we pour water on the roof of our home, what will happen? The liquid will evaporate, or the water will evaporate. Then when water will evaporate, some molecules are there. So the energy removed from the vaporized liquid will reduce the temperature of the liquid, resulting in evaporative cooling. That means here we have some molecules here, that water molecules are, some of the molecules will escape from the liquid state to gaseous state. That means this liquid is, they become liquid to vapor. So they are in the process of changing of liquid to vapor. So when this happen, the energy removed from the vaporized liquid. So the energy, when this happen, the energy will remove from here in the vaporized state, and this energy will reduce the temperature of the liquid. And here this is liquid, and some of these surface liquid molecules will become the gaseous substances or vapor state. Then what will happen? They will remove some energy, and this energy will reduce the temperature. This energy will reduce the temperature of the interior molecules of the liquid. That is why the evaporation happens. Okay, I hope you understood how the evaporation cooling happens. That is, when we pour water, what will happen? The surface molecules will try to change from liquid state to vaporized state. Then there will be some air energy will be releasing when it happens. So that energy will reduce. That energy will reduce the energy of the interior molecules, or reduce the temperature of the molecules at the liquid. Then the evaporation happens. So the energy removed from the vaporized liquid will reduce the temperature of the liquid. That is why evaporative cooling happens. This is one example is that, as I said, when we pour water on roof, we feel the cooling. That is one example. Another example is when we pour acetone on our palm, then also we feel some cooling. That is also because of the evaporative cooling. That means when we pour acetone, the liquid surface molecules of the acetone will evaporate. Then that molecules will pour out, or some energy will be removed from that vaporized liquid, and that energy will reduce the temperature of the molecules in the liquid. That is why the evaporative cooling happens. Then if we look into the evaporation, here always when we think about this evaporation, not think that all molecules are escaping from the liquid state to gaseous state very fast. That will happen, but it will take some time. Only a fraction of the molecules in a liquid have the heat energy and will escape. So once it happens, when it happens, that means these liquid molecules, these surface molecules will escape from liquid state to gaseous state. First some molecules will escape, then after some time some molecules will escape, and finally the complete evaporation will happen. Then when this evaporation happens, these molecules are the surface liquid molecules are going to the vapor state, and this is continuing, and these vapor state molecules are also trying to come to the liquid state. That will happen when our vessel is closed. It will happen when our vessel is closed, the molecules in the vapor state also will come into the liquid state. Once the equilibrium reached, the rate of the molecules escaping the liquid, that is evaporating, equals the rate of molecules returning to the liquid. Okay. There will be a dynamic equilibrium will be reaching in the evaporation. That time the rate of evaporation will be equal to the rate of condensation. Rate of evaporation will be equal to the rate of condensation. Will be equal to the rate of condensation. When this equilibrium reached, the pressure is exerting at the vapor. That pressure is called it as vapor pressure. Then this evaporation, we are familiar in the water system. That means we know that when there is a sunlight, what will happen? Our lakes or rivers, the water in the lakes or rivers will evaporated, and that means the molecules will try to go to the liquid vapor state, from liquid state to vapor state. Then what will happen? The condensation happen. That is why we'll get rain. We all are experienced in our chemistry lab. If we keep some ethanol or acetone open, what will happen? After 1 or 2 hours, the whole ethanol will be evaporated. What is the reason? The reason is that the surface, the same reason what we have seen here, that is the surface molecules are trying to escape from the liquid state to vapor state. That is fast in the case of ethanol and acetone. Because of that, this ethanol and this acetone are all evaporating very fast compared to our water molecule. Next thing is that when we look into evaporation, so if we keep all these things like liquids, if we keep open, in the case of acetone or ethanol, it will evaporate fast, and some of the liquids, they will evaporate when we apply some heat energy. That means when we apply temperature, the kinetic energy of the molecules in the liquids will be higher. Because of the high kinetic energy, what will happen? The evaporation, that means the molecules will try to change from liquid state to gaseous state. Then what will happen? The evaporation will be faster when we apply some heat energy, or as the temperature increases, the kinetic energy also will be, kinetic energy of the molecules also will be higher. Next, we move on to the theory of evaporation. That we have the molecules like this in the case of liquids. there are some empty spaces or free spaces between themselves, and here the surface molecules are getting some higher energy compared to the molecules at the interior, and the molecules at the surface would overcome, they are able to overcome the intermolecular phases, intermolecular forces, and since they are able to overcome the intermolecular forces, since they are at the surface, what will happen? They can easily escape from the liquid state to vapor state. That is the reason for evaporation of a liquid. I repeat once again, that is, in the case of liquids, the molecules are like this. That means there will be some empty space between themselves and there will be an interaction. The molecules are having some interaction. Then what will happen? They will exchange, when they move, they will exchange some energy also. And when we look into this molecule, the intermolecular forces are higher at the interior. At the surface, the intermolecular forces are not that much strong as the molecules at the interior. Then what will happen? The molecules at the surface can easily escape from the liquid state to gaseous state. That is why the evaporation happens. I hope you understood the theory of evaporation. Then this evaporating tendency of liquid varies from liquid to liquid. If you take water, the evaporating tendency will be different, and if you take ethanol, that will be different. Acetone, again it will be different. And if we take different liquids, the evaporating tendency of the liquids will be different. Next, we are going to see the factors which affect the evaporating tendency of the liquid. The factors are, first one is temperature, second one is surface area, and third one is nature of liquid. Then we have humidity, then wind also is another factor which affect the evaporation of liquids. I repeat once again the factors which affect the evaporating tendency of liquids. First one is nature of liquid, second one is surface area, third one is temperature, fourth one is humidity, and fifth one is wind. Now let us see each factors one by one. The first factor is nature of liquid. That means we know that in some of the liquids the intermolecular forces are very strong. In some of the liquids the intermolecular forces are not that much strong. If we take water molecule, there the intermolecular forces are so strong. The water molecules are joined, or the forces are hydrogen bonding. They are having a strong intermolecular attraction forces by hydrogen bonding. If we take ethanol, there the hydrogen bonding is not that much strong as water molecule. And if we take diethyl ether, the hydrogen bonding is negligible, or we can say that there is no hydrogen bonding. So let us see how the bonding in these liquids. Here, if we take water molecule, here if we take water molecule, there is separation of charges. This water is having partial negative charge, and this hydrogen is having partial positive charge, and this hydrogen is having partial positive charge. And here another water molecule is here. Here another water molecule is here. Okay. So there will be a hydrogen bonding between this hydrogen and this oxygen, and this hydrogen and this oxygen. This hydrogen bonding is strong in the case of water molecule. When we look into ethanol, here one ethanol is there, another ethanol is here. So here there is a hydrogen bonding. And another example is dimethyl ether. Here if the hydrogen bonding has to come means it has to come like this, this CH3 of this one and then CH2, then O, CH2, CH3. This is diethyl ether. Okay, when we look into this water molecule, this ethanol and this diethyl ether, in the case of water molecule, the hydrogen bonding, the intermolecular attraction is so strong. Therefore, it is very difficult to evaporate compared to the ethanol and diethyl ether. In the case of diethyl ether, there is not that much intermolecular attraction. Therefore, this diethyl ether is easy to evaporate, and when we look into ethanol, that also easy to evaporate. But when we compare ether and this ethanol, ether will be evaporating fast, and in the water the intermolecular forces are so strong. Therefore, it is very difficult to evaporate compared to ethanol and diethyl ether. The next factor is surface area. The surface area means if the surface area of the liquid which occupies is very large, then it is easy to evaporate. And if the number of surface molecules are more also, it is easy to evaporate. So, if we take the liquid in a small test tube and the same liquid in beaker, the liquid in the beaker, then if we allow them to heat, the beaker in the liquid will evaporate fast, because in the beaker the water in the beaker will evaporate fast, because in the beaker the surface area is maximum, but in the case of test tube the surface area is minimum, and the surface molecule is also maximum in the case of water in the beaker. That is about surface area. And the next factor is temperature. If the temperature is high, the evaporation will also be high. That means when we apply temperature, the kinetic energy of the molecules will be higher. If the kinetic energy of the molecules are higher, then the evaporation will be fast. The rate of evaporation will be fast. That is, the rate of evaporation increases with increase in temperature. Here we have another two factors also, that is humidity and wind speed. Humidity and wind speed. Humidity means the amount of water in the atmosphere is high. That means if the amount of water in the atmosphere is high, what will happen? The evaporation will be slow, because the atmosphere is filled with water, then the evaporation will be slow. Then that is what here shown. Here this is the open container, some liquid is there the evaporation will be fast. But in the another container the same liquid and we have covered the container, then what will happen? The surface molecules will escape, and once it goes there, what will happen? The vaporized molecules will try to come to the liquid state, and here the evaporation will be slow. Then another factor is wind. Here the wind speed means if the speed of the wind is high, then the evaporation also will be fast. That means when the wind is there, the atmosphere is changing. Once the evaporation started also, if there is wind, the evaporation will be fast. That means in the atmosphere that water vapor content will be going by the wind, then the evaporation will be faster. These factors we have already seen. If the surface area is high, then the evaporation will be fast. If the surface area is low, the evaporation will be slow. Then if we apply some heat, the evaporation will be high, and if we are not applying some heat, the evaporation will be low. These are the different factors which affect the evaporation. I hope you understood what is evaporation, the theory behind evaporation, and the factors which affect the evaporation. Now let us see some about the vapor pressure. The same way we are taking the water in a container, and we are taking water in two containers, and one container is open, another container is closed. What we can see that when in the open container, after some time all the liquids will be evaporated, but in the case of closed container, what will happen? After some time, the evaporated liquid will come into the liquid state also. That means once the liquid surface molecules will become the vaporized state, they will try to come to the liquid state. That means the condensation happens. So when this condensation happens, there is exerting that means once after this evaporation, at a particular time, the rate of evaporation is equal to the rate of condensation. That time, there is some pressure exerted by the vapor. That pressure is called as vapor pressure. Vapor pressure is the pressure exerted by the vapor when the rate of evaporation is equal to the rate of condensation. That is, here the number of molecules returning to the liquid and the number escaping become equal, at which point a dynamic equilibrium exists. That is, at this stage, the rate of vaporization is equal to the rate of condensation. The pressure exerted by the vapor is called the equilibrium vapor pressure, or the vapor pressure of the liquid at that temperature. In another way, we can have the definition of vapor pressure. That is, the vapor pressure of a liquid at a definite temperature is defined as the pressure of the vapor in equilibrium with the liquid at that temperature. In brief, what is vapor pressure is that the pressure exerted by the vapor when the rate of condensation is equal to the rate of evaporation. And this vapor pressure also depends upon the magnitude of the intermolecular forces present and on the temperature. The two factors which depends upon the vapor pressure, that is the magnitude of the intermolecular forces and temperature. I hope you understood what is vapor pressure and the theory behind the vapor pressure. And the factors which affect the vapor pressure, let us see in another module. Thank you.